A farmer with 4,000 meters of fencing wants to enclose a rectangular plot that borders a river. If the farmer does not fence along the river, what is the largest area that can be enclosed? Let's first make a concept drawing so that we can visualize what's happening. Here's our rectangular plot, and we're not going to be fencing alongside the river. We want to enclose the maximum area using the 4,000 meters of fencing that's provided. The first thing that we need to do is to get our area function to depend on one variable, and usually we'll let that variable be x. We can let either the length or the width be that value of x. In this example, let's choose x to be the width. We start with what we know about the area of a rectangle, which is that it's length times width. And then what we need to do first is to rewrite this area function so that it depends only on that one variable, x. We'll substitute x in for that width, but we need to figure out what we're going to substitute in for the length in terms of x. So to formalize our task here, let's say that we need to find a substitution for the length in terms of x. Now, generally speaking, the way that we go about doing that, if we want to replace length with the variable expression in terms of x, we need to find an equation that involves only those two variables. And once we have that, we'll solve for the variable that we're trying to eliminate, which in this case is L, the length. So now we need to dig back into the given information and find an equation that involves only the length and x, which by the way is width. And of course it can't be the area since that's what we're trying to rewrite. And this is where the 4,000 meters of fencing comes into play. The fact that we have 4,000 meters of fencing means that these three sides are going to add up to be 4,000. Because the width is x, we can say this side is also x. And since we started with 4,000 meters and then bent up two x sides, we could say 4,000 minus 2x is going to be what remains on this length side. So that's one way to come up with our substitution for length. However, a more mathy way to do that is to use a perimeter formula. The length of fence that we're going to be using is 4,000, and that fencing is going to be split up into two of the widths plus one of the length sides. Again, this is the equation that we're using that involves only x and L, and we're going to then solve this equation for L to come up with our substitution for L. So we'll subtract 2x from both sides, and this is how we would come up with our substitution for L algebraically. So now that we have both the length and the width in terms of x, it's time to substitute those quantities into our area function. So area as a function of x, in for the L quantity, we will substitute 4,000 minus 2x, and in for the W variable, we'll substitute in just x. Let's distribute the x in and simplify the function. So we have 4,000x minus 2x squared. And let's rewrite this in descending order so that it's a little bit more obvious that the graph of the area function is going to be a parabola that's opening down. The reason why we want to get the area as a function of one variable is so that it can be graphed in two dimensions. X represents the width of the garden or the field, and the vertical axis is going to represent the corresponding area for some given width. Notice that the area evaluated at 0 is going to be 0 because when I plug in 0 for each of these x values, the output is 0, which means that the ordered pair 0, 0 is a point on our graph. But if we think about that from our concept drawing, that should also make sense. Remember, x, the input value, is the width. If there's no width, that means basically the fence is just laying straight down by the river. So it's not enclosing anything, and there's no area. Again, we said this area function is a parabola opening down. So in our concept drawing, let's just graph some parabola opening down, and the directions asked us to find the maximum area, and that maximum area is going to occur at the vertex of the parabola. In order to find the vertex, we use the formula x is equal to negative b over 2a. So with our function, the x coordinate is going to be the opposite of b, which is 4,000, divided by 2 times a, which is negative 2. So this will be 4,000 divided by negative 4, or 1,000. So the x-coordinate of our vertex is 1,000. In order to determine the corresponding y value of the vertex, we need to take that 1,000 and plug it back into our area function. So let's do that. Again, the area function was -2 times x squared plus 4,000 times x. And in for x, we plug 1,000. And now we evaluate. This becomes -2 times 1 million plus 4 million, which turns out to be 2 million. And we were measuring in meters, and since this is area, the units of our output are going to be meters squared. Let's update our vertex here so that the y-coordinate reflects the total area. Now let's go back up to the beginning to make sure that we've answered the question. The question asked us to find the largest area that can be enclosed, and so our final answer would be that 2 million meters squared.